Hello, we are team number 15, also known as the Accelerators, and today we will be presenting our Python Edge Detection project for our Engineering 133 class during the fall 2020 semester. The team is comprised of Kumlayak and Leah,
Avad Bavkar,
Kirunda Kunyiha,
and Aditya Saxena.
So a quick walkthrough through our project process. When we first received the project, we decided to generalize the project and goal set, and then eventually we just divided the work up into sections that we believe that each person could do. For example, the input of an image and grayscaling were paired together, and in general that it included a lot of research, collaboration, and then in the end we were finally able to finalize the code.
We then used a Gaussian filter to blur the image. We decided to use a Gaussian filter because it has the best retention of the edges. We just passed a 5x5 kernel over each pixel and applied it using a user-defined function that we used to apply all the filters.
And using that same function, we applied edge enhancement filters like Sobel in both the horizontal and vertical direction to detect the edges. And then after all those edges are detected, we then compute the magnitude of the edges in both directions to get the edges for the whole picture.
The last step is thresholding the image. We just use a simple inequality using NumPy. We tune that threshold value that we threshold the image by based on running a bunch of images and tuning in a value that would give us the most detail while preventing noise. Then we just output it and finalize the code. So here's a quick overview of our software. So here's our main function. We begin by converting the image to grayscale. Then we use that convolute function that KK talked about to apply the Gaussian filter. Then we use that same function to apply the Sobel filters. And we compute the magnitude of the vertical and horizontal edges. And then the last step is just the thresholding value. And we threshold it by this tuned value, which is 0.23, which we just came across by running a bunch of tests. And then we just output to a file. So here is a demo of our software. So here's our 4 Python files. And then we have these 2 empty folders, input and output. So to run the program, we just copy the files that we want to edge detect. Here's an example arch, and here's a space station. We'll throw these 2 into the input folder, and then we'll run the main.py file. I'll have that open here. It's going to start by asking us for the name of the file. And if I misspell it, for example, it's going to tell us to rename it properly and enter again. Enter properly, it's going to start its computations. So the first step is converting to grayscale. Then the second step, which takes the longest, is the Gaussian filter. This is a 5x5 kernel, so it has to do 25 calculations for every single pixel on the image. So understandably, it takes a little while for some of the larger images like the arch. Now it's computing the vertical edges using the Sobel filter. And using that same filter, or different filter, but same function, we're computing the horizontal edges. And finally, we should be computing the magnitude of the edges and then thresholding the image, and then gives you a preview of the output image here. And if you go to output, we can see the resulting image right here. Let's run this program once more with the space station example. Again, here's it before. And space station.png. This one's a lot smaller, so it should take not as much time. There it is in the console. You go here, there's our output image. So that concludes our demo of our code. Thank you for watching.
Thank you.